Hello, welcome to the AM podcast. I'm your host, Yijia. Today we have Omar Shaikh in person to talk about his work on bridging the grounding gap between humans and AI.
The reason I think this idea of a general user model will help continue to bridge the grounding gap is because people build grounding using strategies beyond dialogue all the time. I think it's nuts that the systems we use today are super reactive, and we have to constantly be filling in this grounding gap through dialogue. I think there must be an easier way to interact with computers. There's a little demo that we worked on with a general user model where we took this tab to autocomplete idea and we put it everywhere. So you can literally open Google Docs or open Slack and you can just hit tab. You have this user model in your code base that understands you well enough to do the right thing at the right time. It has your context, it has comments, and it's auto-completing. I love this idea. I guess this is a meta mind-blowing one. When I was working on the system itself, it would generate inferences about me working on the system.
Oh wait, yeah. This is hilarious.
Yes.
It's like a self kind of improving
stuff. It was
stuff.
so weird.
This brings back to why this human-centered technical work is really important. It's it's really unlock a lot of potential. Hello, welcome to the AM podcast. I'm your host, Yijia. Today we have Omar Shaikh in person to talk about his work on bridging the grounding gap between humans and AI. Omar is 1 year ahead of me in the Stanford PhD program, and I still remember back even when I was just rotating in my advisor's group, I directly told her that I hope to collaborate with Omar. This is because Omar's approach to connecting AI modeling with interaction design in HCI was genuinely eye-opening when I first arrived at Stanford. Beyond his technical work, Omar is a nice, passionate, and inspiring researcher who deeply cares about both tech and humanity. I'm sure you'll feel that in our podcast today. All right, Omar, take it away.
Hi folks, I'm Omar. I'm a fourth-year PhD student at Stanford, and I'm super excited to be a guest on the AM podcast. So I think it's a little bit weird that our primary interaction paradigm with LLMs is centered around us asking for help. I mean, if these models had access to even a little bit more context, maybe the file we were following before, or the calendar events we just wrapped up, or the Slack thread we were interacting with all morning, our task would be a lot more obvious to these models. So even when we do prompt models with a task, we're always really, we're just bound to leave things out. It's really impossible to take all of your rich context and turn it into a single text prompt. So my work thinks a lot about good models of user grounding or context. One direction I've worked on are general user models, or GUMs. GUMs use multimodal models to build a general understanding of your context through observation, specifically through all of your computer use. GUMs build this understanding by collecting a set of propositions about you in text. So maybe what you're working on, what you're interested in, etc. So now when I go to a model, it already has all of this context, and I don't have to supply it in the prompt. A general user model works in 4 steps. It first observes and transcribes what's on your screen with vision language models. And then from these observations, it proposes inferences about you. It'll also retrieve past propositions to help generate new ones. And finally, it'll revise past propositions as it observes more. If you have a collection of these propositions, you can build a whole host of interactive applications that know you so well that they can kind of do the right thing at the right time. So you can build assistants that proactively do things for you because they have all this context about you. And that's kind of exactly what we did in this project. I'll read through a few propositions that my GUM made about me while I was preparing for this monologue. Things like, Omar is switching between looking at old slides and making notes for this monologue. Or Omar is coordinating with Yijia on where to meet for this monologue. Or Omar likely hasn't been on a podcast before. So I'm super excited for this, and I hope you guys enjoy what I'm about to talk about.
Hi, Omar. Welcome to the AM podcast.
Yeah, thanks for having me. I'm super excited to be guest N on the podcast.
Also
honored.
Thank you so much for sharing this very, very cool project with us. I know in the last 2 years, you are actively working on bridging the grounding gap between human and AI. So how is the GUM project kind of connected with this broader goal?
Yeah, I think what surprises me is the ways we build common ground with people, for example, has been a pretty strong inspiration in my work. When we interact with people on a day-to-day basis, like we build grounding through a ton of strategies. Like I think one of them is like QA. Like I'll ask you like, what is this podcast about? Because I don't know. And then you'll tell me this podcast is called Augmented Mind, and we have some kind of gap that's filled. But I think like the reason I think like this idea of a general user model will help continue to bridge the grounding gap is because people build grounding using strategies beyond dialogue all the time. Like I know I'm on this podcast right now because I can observe like this awesome setup you guys have put together really quickly. And I'm not going to ask you questions like, where are the cameras? Because I can see the cameras. And I think like when we interact with computers today, like the kinds of strategies we use to ground are limited to just like instruction following and question asking and like a back and forth dialogue. And I do think, this is not me saying I don't think it's important. I think it's important for us to have like dialogue as an interaction with computers. But I think like we need to expand beyond this like silo of chat and have models observe like more extensively sort of what we're doing on our computers in like private ways. And I think that unlocks all kinds of awesome interaction paradigms.
Yeah, this makes sense. So when you are showing me all those very cool propositions coming out of the demo, I do notice like next to them, there are also some numbers. So what are those numbers actually stand for?
Yeah, so if you look at like a handful of these inferences from the general user model, like there is like a number that ranges between like 0 and 1. So like I think one of the inferences that I think is really fun to like talk about is like, Omar prioritizes communication with his advisor over other people.
What's the number for this?
Like, right, the confidence on this is like 0.6, 0.7.
Is this high or low?
Right, I mean, it ranges from 0 to 1. And I think I can explain exactly why this confidence number is important. But it's funny, because it watched me like, when I open my Slack, I immediately go to D and Michael instead of other people. Sometimes my brother messages me. I still open Slack before I like message my brother, which is kind of ridiculous. But I think like for inferences that are a little bit more subjective or a little bit more far-reaching, you kind of need people to know whether or not like this model is actually confident in its assumptions about you. So what we have beside the proposition text is like this, like literally this confidence score, which is the thing that ranges between 0 and 1. And confidence is super important for users because they want models that are calibrated.
Okay, so you just mentioned calibrated. I do know like this is a common term kind of in machine learning where you try to see like whether you are confident enough with your prediction. So how is the concept transferred to the user modeling concept?
Yeah, right. Calibration is super interesting in like QA. So I think or like factual like tasks, like simple QA or whatever. But I think to give a high level summary of what calibration is. I mean, everyone here has like a weather app, right? Like we pull up phones, we look at the weather. It's going to be raining today. Your phone doesn't tell you. These weather apps don't tell you like it's raining or it's not raining. They kind of have like it's going to rain 70% of the time. And depending on that, you'll like look at that confidence and you'll make your decision based on whether or not you want to bring your umbrella. It was like the raining the last few days here, and my phone was like raining 20% chance, and I didn't bring my umbrella and I got rained on.
So I guess like for their 20% of the chance, they are kind of based on some sort of like algorithm to predict that. So like when you say the user model also has this calibration,
yes.
How does the calibration happen? Right?
Yes, right. So I think like the way people elicit calibration from language models is they literally prompt the model for something called verbalized confidence. So you prompt this model to express a confidence score between like 1 to 10, or in the general user model case, 1 to 10, and then you normalize. But
it's more like just prompting the model to generate the number?
Yes. Right.
Oh, that's super simple.
No, it is super simple. What's surprising actually is there are interesting results when you look at like I think the GPT-3 paper, and they show you like what happens after they train this model to instruction follow. What happens is your underlying logit, when you look at the logit on like the model's like output token, it's actually not calibrated. So if you look at like the probability distribution of the potential outputs this model could generate, like it's super confident in that probability distribution, which is super weird. And this only happens after you train your model to follow instructions.
But so basically, if you just start with a base model, you found the logits, they are not calibrated. But after instruction tuning, the logic suddenly become calibrated, or?
No, right. So the base model is calibrated.
Oh.
The base model is calibrated. Like the logits are actually calibrated, but after you instruction follow, they become super peaked.
Okay.
And what's interesting is that you can actually just prompt these models to generate the confidence like token instead of looking at the logit on the token, and that ends up being like calibrated.
Oh, this is actually a very interesting point, because when you are trying to use the calibration concept in user modeling, you actually found if you only based on the logic,
Yes.
the instruction tuning is
Yes.
actually making things worse.
Yes. I mean, this is like a result that's sort of well known in the community, but I think what's surprising about the general user model case is like we extended this idea to like literally user modeling. Like observe
I
what a
think
person.
this part is not really known by the community.
Yeah.
Right? It's like a pretty out of distribution domain.
Yes, it's pretty nuts. I think like even in this out of distribution domain where you like your model is conditioned on literally everything the user has sort of been doing, when you ask it to generate inferences and also generate confidence scores, empirically, like these confidence scores are also like well calibrated.
I actually have a question. When you say well calibrated, how can you actually verify this, since
Right.
the user modeling is also a fuzzy domain, right?
Yeah. So I mean, we had to like run a user study with
I
a
see.
bunch of users, and we had them like run this like general user model on their computer over like 5 days. And we
I'm thinking, suppose I'm a participant, and if you ask me to rate a confidence about like certain argument about me,
Yes.
it might be hard for me to even provide confidence, right?
Yes. 100%. It's hard. So, I mean, all we really do here in terms of like quantifying confidence is we ask people to label whether or not the inference made about them is correct or incorrect.
Okay.
So we sample a bunch of the inferences from their general user
So
model.
user is providing binary signals.
labels, right?
Okay.
Right. So the user is providing binary labels, and what we do is we take the model's confidence score. So you have this binary label, like sort of 0 and 1, and you have this confidence score that's also between 0 and 1. And what you do, this is called the Breer score.
Can we see a bit more about this?
Right. So the way the Breer score sort of works is you subtract your label from your predicted probability, and you compute like the mean squared error. So you see how far off your predicted probability is from your actual label. And if like your model is like confident when it's accurate, and it's like 1 minus 1, sort of collapses, to, and your Breer score is 0. But if your model is always like, confident when it's incorrect, then you have a mismatch, and your mean square error goes up. So it's a super simple metric. We apply this metric in the general user model paper, and we find that like things are surprisingly well calibrated. We also have a calibration plot, and what's kind of surprising, you can actually literally plot like accuracy on one axis and confidence on another. And if accuracy and confidence kind of like when you plot these aggregate metrics on your curve, if like y equals x, then you know that like when the model is completely confident, then it's accurate. When it's like not confident at all, it's like inaccurate. And we did this for a bunch of users, and we find that like it's surprisingly, even in this crazy user modeling domain, we have pretty calibrated models. Yeah.
Okay, so let me just summarize a little bit for our audience. So
Yeah.
now, the work is not only contribute like the user model part, but also for each proposition, it comes together with a confidence score.
Yes.
So I can say, okay, now I have a user model that really know very well
Yes.
about you and also well calibrated.
Yes.
Then, given this, what does it really mean, right?
Yes. Yeah. I mean, like, okay, I think like calibration, like I think there are many awesome things that sort of come out of calibration, especially in the user modeling setting. The first thing is like users can kind of easily inspect like inferences that the system made about them and know like, hey, how confident is the system about like the inferences it's made about me? Because I mean, you don't want this like model to be making like
But
inferences.
why will the user actually reading this information about
Yeah,
them?
right. So this is the first, like if a user actually wants to interpret or like sort of look into like the model's like innards and sort of see like, here's a representation of like where I want to like edit or like adjust these things, they can. But I think the other interesting application here is like, if you want to use this to power a system down the line, like an interactive assistant that suggests things for you, then you can rely on this confidence to determine whether or not you should actually help the user with this thing.
By suggest, you mean something like recommendation system, this
Yes.
type of thing?
Yes. So I mean, like for recommendation systems too, or like or assistants, I mean, I think one of the applications in the general user model paper is sort of like an interactive assistant called Gumbo. What it does is it uses the inferences from the general user model and it generates suggestions based on these inferences. Now, if you have a confidence score associated with these inferences, then only if you're highly confident that a user kind of needs help, you're likely to generate a useful suggestion. And there's a whole framework behind this called mixed initiative interaction. Like, when should you take initiative? You should only really be taking initiative when you're confident that the user needs help and like the utility of helping the user is quite high.
Wait, so basically this is also connected to, I think, a concept called mixed initiative system. But
Yes.
actually there is a hidden assumption saying people actually want AI or like the system to sometimes take initiative, right?
Yes.
But I do feel like some people may just argue saying, well, I just want the AI or the system to be my tool. Why
Yes.
need it to take any initiative?
Yeah, I mean, right, I think like there are cases where your model might do something that like you didn't want, right? Or it might suggest too many things to you.
Yeah,
I mean, like
that's a concern.
I don't know if I like, I mean, I feel like when I make the Clippy joke in front of people, sometimes people are like, what's Clippy? But
Yeah, what's Clippy? Actually, I think this would be, some of the audience may not know. Maybe you should talk more about
Okay,
it.
back in the day, before your time. No, I'm kidding. I don't know how. Anyway, like Microsoft Word had this like assistant, this like Clippy thing that'd be like, hey, do you need help? Like with it seems like you're writing a letter. Do you need help? And this like literally a paper clip. I made this joke in like a class that I was like guest lecturing in, and there were like kiddos in the class. I was like, does anyone know what this is? And they were like, I don't know what you're talking about. So I had to work on this bit. But Clippy was this assistant that would observe what you were doing in like Word, and it would like offer you these suggestions. And one of the failure modes with Clippy was that it would interrupt you all the time, right? So I think like what's really important is even if people are using this AI as a tool, like people want like some agency in terms of when this tool should do things. And like the way you instantiate whether or not people get agency is like you interrupt them. You go, hey, like, do you want me to do this task? Oh, hey, I noticed that you're easily distracted by like ice cream recipes. Like, maybe it's time to like get an ad blocker.
Yeah, probably not good if now suddenly it suggests us to do some ice cream stuff, right?
Right, yeah. So I think the cool thing about like mixed initiative interaction is it delegates some of these decisions back to the user. And what you need for mixed initiative interactions, you need two things. The first thing you need is a good estimate of how confident the model actually is.
So you mean how confident they are about like the proposition
Yes.
you get from the people?
Yes.
Okay.
Yes. And I think the second bit is also like an estimate of like utility. Like how much benefit does this task actually give the user? And if you have these two pieces, I mean, there are a couple more pieces, you can compute like an expectation. You can take like the likelihood of this inference actually being correct, which is the calibration thing we talked about, and you can take like the utility of this like suggestion actually providing benefit to the user. And then you can compute like the expected utility of interrupting the user, the expected utility of not interrupting the user, and you can compare both of these quantities.
So how is like these two factors work together? So it's like through some sort of like a multiplication, or it's like more complicated stuff happening under the hood?
Really, like it's a simple like expectation calculation. It's just like you're multiplying the probability of
it's
this
using
inference.
like expectation.
Yes.
I see.
Yes.
That actually makes sense.
Yes, it's super straightforward. I think but I think the hidden thing that's tricky about like computing like this expectation is like you need to like back in the day, I think like one of the failure modes of Clippy was that you wouldn't really have a way of getting confidence. You also wouldn't really have a good way of getting the utility that this would provide to a user. But now that you have a general user model with all of these inferences.
Wait, but you didn't really explain how the utility is obtained, right? Because based on my understanding, GUM, the user model,
Yes.
provides the confidence part.
Yes.
But like, how do we know whether executing a certain thing based on the proposition will give us certain utility?
Yes. I mean, again, what you can do, and this is like recursively reusing the GUM, which is kind of tricky. Right, yeah. So what you're doing is you generate a handful of like potential candidate suggestions. So you might generate things like, let's say I'm looking at ice cream recipes, right? Something I do all the time. You might generate like tasks like condition on the GUM, condition on inferences from the GUM. You might generate tasks like help Omar find more ice cream recipes, or notify Omar that he should probably be working on like preparing for the podcast, right? Like, so I think there are a handful of these candidate tasks that your model can generate. And then what you can do again, condition on these candidate tasks in the GUM, is you can elicit a utility score. Just like how you elicited confidence, based on like everything the user has sort of been doing. This is all sort of in the GUM. You can put all that in context and also generate a utility score.
So basically the GUM also serves as a context for calculating the utility.
Yes, yes.
Okay.
So you elicit both of these scores, right, from the model, and you can use that to compute like a threshold.
This is actually pretty interesting because I think one core challenge of like this type of human-centered AI right now is about like memory, especially long context memory. But it seems like GUM actually provide a very solid base for this, right?
Yes, yes. I think like a lot of the abstractions in this GUM system, I think are super important for all kinds of like more general purpose memories too. I think in the chat, like it's interesting because in the chat interaction paradigm, it's pretty easy to sort of construct confident memories about the user. They'll sort of just tell you what they want or tell you what you want to do. But I think the powerful thing about like a more general user model is you have to construct these inferences from literally anything the user does. And I think like this increases like the surface area of all kinds of cool things that like interactive assistants can do for you now. They don't know you just based on chat. They know you based on like everything you're doing.
But I guess you are still solving a harder problem because when you say like mixed initiative system,
Yes.
I actually view it as a more complicated problem than full automation system because now the AI also need to know whether I should even take the action, right?
Yes.
So actually you are, even though you are saying you are kind of providing the foundation for solving many problems,
Yes.
but this problem itself is actually pretty challenging.
Yes. Yeah. Like, I think like encoded in like I guess the central thesis of like this GUM work is like shining a light on like the mixed initiative interaction paradigm and going like, hey, now we can revive this. Like now we have estimates of like utility. We have estimates of confidence that are like, that we have sort of tested and evaluated. And they work well beyond things like just Microsoft Word. I love Clippy. It did a lot for the community, but like I think like we can take another swing at it.
Yeah, this is very interesting. I'm actually wondering, like, this project seems to involve multiple parts, right? What's the motivation that drives you to do it at the first place?
Yeah, okay. My honest motivation is like, it's ridiculous that we're still prompting language models. Like, think about how crazy that is. Like, we like open our computer, we're having all kinds of problems. I mean, again, it's motivated by like the grounding app, but like you have a problem. Like, I mean, you're working on your code editor or whatever, you have some bug, right? And then what you have to do is you have to do this ridiculous thing where you look at like everything you've been looking at in your code base, and you look at all the possible problems that you may have had, and then you open like that, Cursor tab or ChatGPT or God knows what.
Coding is already an easy case because like the IDE really provides a nice place to put all the files together, right? But suppose you are navigating between apps, that's even crazy.
I mean, I think what's still nuts to me is like even in the IDE setting, like you still have to construct the task. You have to be like, like for example, if you're running into like an error with your code, you still have to tell Cursor like I am running into this error. That's ridiculous. Like you have so much context on what the user is doing. Surely Cursor could be like mixed initiative or like anything you do on your computer. Like when you extend this beyond like coding IDEs where like you have a very careful environment, like I don't know, email. I look at my email and then I look at my calendar. Like for example, I mean, even preparing for this interview, like I'm opening like messages with people. I'm opening like emails. I'm opening like my Slack. I'm opening all kinds of things.
And also the Notion stuff, right? It's like how many tabs you are opening?
Probably 1,000, right? And I'm also there's also an ice cream recipe tab. I'm distracted. So I think like I'm super distracted about all these things. My context spans across multiple things, and then I have to go to ChatGPT and tell it, like, take all of this context and manually put it into a prompt and say, I'm working on this thing right now. I am meeting with, like, Ija and Shin and tomorrow. I have to, like, set all this stuff up. It should know that. In fact, not only should it know that, it should already be doing it for me. Like, it knows, like, if it had a good estimate of how confident it was that I was struggling, 100% confident that I was struggling, and how much utility this thing would give me, then it should do that. I think it's nuts that, like, the systems we use today are super reactive, and we have to constantly be filling in this grounding gap through like dialogue. I think there must be an easier way to interact with
Yeah,
computers.
this actually reminds me, like even for cursor, like now they are having all this kind of agent mode.
Yes.
But before that, it's really the tab feature.
Yes.
And makes it really successful because people they can just choose to whether accept or reject.
Yes.
It's pretty easy.
Yes, like I think tab to autocomplete. So there's a little fun demo that I worked on that I'll probably just like tab to autocomplete. I think is a super cool interaction because it knows your task well enough to like. I mean, in a sense, tab to autocomplete is kind of doing this like next task prediction thing. Like based on where your cursor is, it's inducing the task in your priorities and it's generating a completion. I think that's such a beautiful interaction where like you have this user model in your code base that understands you well enough to like do the right thing at the right time. Like it has your context, has comments, and it's like auto-completing. I love this idea. So there's a little demo that we worked on with a general user model where we took this like tab to autocomplete idea and we put it everywhere. So you can literally like open Google Docs or open Slack and you can just hit tab.
Oh, really?
Yeah.
Is this already a demo?
Yeah, it's a neat little demo that like it's like the GitHub is sort of there, and I think like the link might pop up. But you can kind of tab to autocomplete wherever you are. And I think the way it works is like again, you've observed everything the user's done on every on like their computer, and you've constructed a good user model.
Basically, it's like tab everything.
Tab everywhere. Yeah, or sorry, or Tabracadabra.
What? Can you say again?
Tabracadabra.
This is a name of the
Yeah,
demo?
like it's like abracadabra, but like Tabracadabra.
Oh no, you're also a Harry Potter fan? I guess?
Well, yeah. I mean, what was the? I don't remember the Harry Potter spells, but I don't think they ever had abracadabra. But yeah, Tabracadabra.
That's super cool.
Yeah, it's funny. I think the examples I had were like, oh, my advisor is like, oh, we have a progress update, and I hit tab, and like I've been working on all these things. So, I mean, this is one like interaction paradigm that kind of emerges when we have these like user models that have a more comprehensive understanding of you. I like to think that like when we break beyond the silo of like narrow user models that we have, like these are the kinds of applications that appear. Yeah, I'm super excited by this.
Yeah, actually, I want to poke into one technical detail. It's like, because when I think about like just tab everywhere, I guess basically your context is like the whole trajectory or action history the user has, right?
Yes.
Then the history will keep accumulated.
Yes.
Then how can GUM know like which part to look at?
Yes. Yeah. I mean, the way like the GUM system works right now is like you observe what the user is sort of doing right now, and you generate a handful of inferences about the user, like just-in-time inferences. Like what is the user doing like right now?
Oh, so basically it's like it also has another process observing what the human is doing now and try to come up with some text summarization.
Yes. And then what you do is you use those summaries as like a query for a retriever. So like, I mean, the implementation for this, like we try to keep things lightweight. It's like a BM25. It's a lexical retriever.
So basically it can actually run on your computer.
Yes.
I see.
Right. So BM25, simple lexical retriever that runs on your computer, and you can like retrieve past inferences about the user, like put them in context. So with this retriever tool, you're no longer limited by just what the user is sort of doing on their screen right now. I think again, like there's a lot of opportunity to like improve on this like retriever and improve on like the general like. It was funny. Improve on the general user.
This project seems to have so many parts, right?
Yeah.
You just mentioned. First is like the GUM part,
Yes.
which is like coming up, inducing the proposition,
Yes.
and also need to ensure it's calibrated.
Yes.
And also, you need to have like this retriever to
Yes.
support it can really handle longer and longer context. And finally, you also work a bunch of very cool demos to showcase how GUMs actually work, including Gumbo and what I call like Tabracadabra.
Yeah.
Right? Like, it's really crazy, like how you just navigate the full stack thing.
Yeah, it was okay. This project was a long time in the like cooking. I think like one thing that I have been thinking about is like the meta of this. I feel like in highlighting like human AI interaction work, I feel like there's a lot of value in like designing like cool interactions that people can sort of immediately see and see the utility of. So I feel like in building the system, like my advisors and I were sort of like, how do we construct interactions that to people are sort of like, yes, like this is maybe how the future of like interacting with language models should look like, or here's what intelligent systems should actually be doing with us. And I think
so this is very interesting because most of the, I think, existing work focuses a lot on capability, right? We want to create a new capability, solve harder problem. But what you're kind of hinting here is like, we also want to design or build a model for new experience.
Yes.
Right? New interaction experience.
Yes. I think there's a lot of like work to be done. Like, okay, this is maybe like a take. I think like there are two sort of communities. There's like the interaction design community and there's sort of like the modeling community. And I feel like both of these communities are kind of like working on like independent things.
Maybe can you say a bit about like what the interaction community is mainly working on? Because I think most of our audience may be more familiar with the AI side.
Yeah, sure. Right. It's like, oh, how do you design like novel interfaces or interactions for like controlling models or like asking models like the right thing or like supporting specific like tools or applications, right? You know, like you have like language models to serve as like simulated like, you know, patients to help people practice like mental health support. You have language models that for like education to help people like learn things. And I think like each of these applications requires designing a new like interface, designing a new like, oh, the user is going to use the language model in this like way. And I think like when you think about like what these interactions look like, you have to like scaffold around your language model. And I mean, all right, so this is sort of the interaction side of things. And I think like the research there is sort of like a lot of it focuses on the interaction.
I see.
And a lot of it sort of is around, you know, scaffolding around the model. And on the other side,
they are not really changing the model.
Yes.
I see.
On the or like, you know, the techniques used to like elicit things from the model are not like informed maybe by like the AI community. But on the other hand, the AI community is sort of interested in like pushing capabilities on like fixed benchmarks. It's like, here's this kind of task that we want to like improve on. And I think like, you know, there is an outstanding opportunity to sort of be building models trained to help people with specific capability, like with specific like interactions in mind. And I think that gap right now is like something that is super like, and I see sort of like, you know, like for the follow-ups to the like the general user model work. I mean, focusing on like this kind of user modeling interaction has inspired a lot of like modeling work that like we're super excited about. I mean, like we even collaborated on like this DITTO project, which is super inspired by like, you know, language models. Like when people want to use language models, the interaction they really want is like language models to like mirror their style. And I feel like alignment right now doesn't really do that. So Yijia and I worked on like this fun project where how do you actually get models to like reflect like the demonstrated preferences of people, like what they actually do.
Yeah, that's a really cool project. I remember it's actually, I started working on that in my first year at Stanford. It's really changed like how I view about algorithm development, because previously I mainly developed algorithm, as you say, is like to hill climb some benchmark.
Yes.
But for that project, it's basically we designed this new algorithm for the sake of a new experience. Because we want people to say, okay, now if I want to just personalize something, I don't need to say a bunch of things. I just need to provide 2 or 3 demos.
Yes.
That is kind of a new experience.
Yes. Yeah. And I think like even with the gums, like I think what I enjoy doing, like when you work in this area, is you get to flip between like interaction design and like now with the gum paper is sort of wrapped up. I'm like, okay, how do you train specialized models to do good user modeling? And like there are no benchmarks, there are no like data sets, there are no like.
I think this is probably the way ahead, right? Because nowadays, if we only work on those traditional benchmark like coding or math, then it quickly gets saturated and it's really limited. Like we are limited by what benchmark out there, right? But what you suggest is like, okay, we want to work on new thing that we can even come up with benchmark for.
Yes, totally. And you can construct benchmarks around these like user-centered tasks. I think like, I mean, it is sometimes tricky when like, I mean, not to like turn this into peer review, but like, I mean, sometimes I worry that like when you work on projects like this, like you kind of might get like in peer review, like, hey, this benchmark is not something we recognize, or like when.
But I think ultimately the value will shine.
Yes, I agree. I mean, like, and I think the other thing that's also awesome about this is like there's sort of like this concern that like the language models are sort of solving all the tasks. And like you make the model bigger and your task will get solved.
But what you are doing is not solving tasks, right?
There's so many things to do. There's so much. I think we're in like this is like the moment to be like all of a sudden like language models are kind of working for tasks people care about. but there are so many things that you can kind of apply these models to where you can like close the gap. And like the amount of opportunity out there is like awesome in this area.
So I'm actually quite curious when you mention like one huge part about this project is bridging the gap between the interaction side and also the modeling side. Is this the biggest challenge you met, or is there something else?
Oh yeah, working on this. There are a lot of man, no, yeah, it's this project was okay. Like elephant in the room, like how in the world did we run this study, right? Like we had to recruit a bunch of it. I think like bridging this gap is also always super fun, but like to run this study, like this is one of the painful things about like human AI interaction work. You have to like recruit participants, you have to run a study, and you have to like see like how do participants actually feel about like using your system and your model. We had this problem with DITTO. I'm sure you remember it was not fun.
Yeah, I feel like in the last 2 or 3 years, I'm gradually getting familiar with this.
No. I feel like a lot of human AI people are like, yeah, you know, it's like everyone can kind of like resonate with this, but like with GUM, what you kind of had to do is you had to observe everything a person did on their computer. And that's asking participants for a lot. And it's also asking like the IRB for a lot. The IRB is the Institutional Review Board. In every university, like a lot of universities have this board where you kind of submit your study on human subjects. And they review it for sort of like risk. Like, does it like, how does it respect like the rights of the participant? And our study, understandably, like really observes everything.
So when you describe the work to the IRB folks, basically I believe they are non-technical people.
Yes.
What's their first impression or reaction?
Their first impression, so already when we submitted this project to the IRB, when you like a tenet of like this idea of like user modeling, it has to be privacy like centered. Like actually all the models in our user study are run on like open source models. So we had to spin up our own infrastructure, and like each participant had their own like node, like well not node, but like 4 H100s where they
That's still pretty computationally expensive.
Yes. Yeah. I mean, one of the limitations of like this general user model, but I think like it's funny because since the paper has come out, there have been like smaller vision language models that can run on your computer. So I think like there is an opportunity to get like to move the infra from like even like our own hosted infra to locally. I think I'm like betting on Moore's law to sort of solve that. But right, going back to the IRB, like before we even went to the IRB, we're sort of like all of this happens on our own infra. None of your data goes to like big OpenAI or big like Gemini or big whatever. And the IRB was like pretty happy with that. So we went to like the privacy office. We went to like.
But it's really good. Like even when you describe the project to people, people quickly understand what's the point, right?
Yes.
You directly point out it's like
Yes.
privacy is a thing to
Yes.
consider.
Yes.
That means you kind of share your project in an easy to understand way.
Yeah. No, 100%. I think like one of the things that I also am kind of excited about is like how do you bring ownership of a user's data back to the user, right?
What do you mean by ownership here?
Right. I mean, already like if you have local models that are doing stuff for you on your own data, then I think we have an opportunity here to decentralize user models. I mean, if we think about user models in the traditional sense, like we have user models of us, like the companies have user models of us like looking at YouTube. They have user models of us in these silos, and they're very like narrow, but they observe everything we do, and they're sort of owned by like big co.
This is actually a very interesting point because this connects back to what you say about calibration at the very beginning. You mentioned it's like for a base model, the logic is kind of more calibrated.
Yes.
And I think one reason is because they are trained on a soup of different people's kind of tasks.
Yes.
But once you kind of do other sort of training, you basically break the alignment.
Yes.
But here, suppose you really bring the ownership back to the user. Then it seems like there's even a better chance to be better than the soup of model people's tasks can contribute.
Yes, absolutely. I think like, I mean, one of the things that follow-up work that I've been mulling over right now is like, how do you build like specialized user models for individuals?
Oh, you're already doing that?
Yeah. Like, how do you collect data from like, how do you allow an individual to scale their own personal data collection to build their own really powerful personal user model?
What's the scale of the data here? I guess our audience, and including me, are pretty curious, like, what's the scale here?
Yeah, I mean, okay, it's like, this is still like work in progress, but...
no worry, you can share any part of it.
Yeah. I mean, it's like you kind of just observe a person using their computer for like weeks.
then it's a lot of data.
It's quite a lot.
Right? Like,
it's quite a lot.
For me, I kind of use my computer more than 10 hours every day.
Yeah, okay, there you go. Okay, that work ethic. Yeah, it can be quite a lot. Right now we're still sort of in experimentation mode. But if you own this model and you own your own data, it's actually quite easy to collect detail, like action trajectories about like what you've kind of been doing on your computer.
Then what's the kind of the training objective? Because I still found the whole GUM work is like a magic to me, because you can think about that. We never train a model to do this kind of thing.
Yes.
But then the magic just happened.
Yes.
Can you maybe explain how this connected back to the training stuff?
Yes. Right. So right now, like a lot of the methods part of like the GUM paper is around like eliciting utility and eliciting confidence and using those to like employ this mixed initiative interaction technique. It's very empirical in nature. I think one of the limitations of a general user model is that you need to be like clever about what you're saving in the GUM. And I think like right now, we're not particularly clever about this. It's not tied back to training.
I see.
But I think like something that I'm really excited about too is like, you know, the point of a general user model is to sort of be predictive. It's to sort of like help you do the thing or like predict what you're...
Predictive, you mean predicting what's the assistant need to do, or like predict what
the user needs to do?
The user needs to do.
Or what, like, you know, I think, right, this can be defined by the user. So maybe the user can define, like, here's an objective that I want my user model to learn towards.
But then how can you really get the supervision signal, right? You can't keep asking people, like, at this point, want to do later.
Yeah. Yes, right. So I think by default, like, the reward on, like, a good user model is, like the design decision we've sort of made is, like, a good general user model should be able to predict generally what you're going to do next.
By generally, you mean?
Across any application, right? So it's like, if I use my computer... my general user model should know that I'm going to be distracted next, right? Like, I think...
Are you now distracting?
No, I'm paying like complete attention. I had like a cup of coffee today, so I'm very wired. Anyway, right, so this general user model should like all the propositions in the general user model should be used to help predict what I'm going to do next. And I think right now we're not really penalizing this model for generating inferences that are not useful for this goal.
I see.
And what we're sort of thinking about is like, you can totally construct like, I mean, in a sense, this task is like easily verifiable, right? Like you generate these inferences about a user, you wait a little bit, and you see if you actually...
This is very cool. Yeah. I didn't really think of that. When you say it's verifiable, I actually kind of, my mind kind of go blank for a while. I feel like this is a super fuzzy task if you ask me to place in this spectrum.
Yeah.
But this kind of makes sense.
Yeah.
It's like you can wait, and it's kind of like the next token prediction.
Yes, totally. It's like next like task predict. Like you just wait a little bit and you see whether or not the person actually... I mean, the way this data is constructed is a little challenging because, you know, when you look at some of the data you collect on your own computer, it's quite noisy. It's like you alt-tab a lot between tabs. You move a lot. So it's very easy to mode collapse on this data.
That makes sense.
So at least in the initial experiments, we've found some like promise with like RL. And the fact that like you can actually construct like a good verifier from this, and like it seems like it's actually quite easy to just see like, did the user actually do that thing next?
Yeah, so basically this is like a rule-based verifier.
Yes.
You don't really need to use any sort of like LLM as a judge.
I mean, so we've been experimenting a bit with LLM as a judge because it's kind of hard to like semantic, like, well, you can use BERT score, I guess, or like some embedding-based method to find out whether or not the person actually, whether or not like the rollout generated by the model actually is close to like the ground truth. But we've been messing with LLM as a judge, and it also seems to, you know,
yeah,
help
I feel
here.
like that go back to the problem, right? Then you need a model to really understand this person very well. So actually, I really like the direction you guys are heading towards. It's like a super simple idea. It's like just view everything as a predictive task.
Yes.
And the signal can also based on just like a time series thing. I feel like I really drawn by a single method, and I feel it's pretty promising.
Yes.
You mentioned you already see promising results.
Yes. Yeah. This paper will hopefully be out soon.
Whoa.
Well, not as in by soon.
Crazy.
I mean like end of January ICML deadline.
That's very cool. I'm kind of curious. It's like now you have a model that knows really well of you, and also you have the method to keep improving of it.
Yes.
What's the aha moment of like the most mind-blowing thing that you see GUM say about you? Don't tell me ice cream. Something else.
No, okay, ice cream.
No
not ice cream, not ice cream. Okay, there are a lot of fun ones. Let's see, what can I say without incriminating myself? Okay, I mean, procrastination helps a lot. It helped me when we were trying to move to San Francisco. So, I knew from, I mean, this has also helped with a participant who was sort of in our user study, where this participant was moving, and it generated it knew they were kind of stressed out because they were messaging their friend about moving a lot, and they were looking at their calendar a lot, and it was like, hey, we think you're worried about moving. Here's a moving plan, and here are people you can go to help you move. So pretty mind blowing. One of the other things that's also really funny, I guess this is a meta mind blowing one. When I was working on the system itself, it would generate inferences about me working on the system.
Oh wait,
Yeah.
this is hilarious.
Yes.
It's like a self kind of improving
It was
stuff.
so weird. I don't think it's aware of itself. Like when I was debugging an issue, the guy was like, Omar is working on the general user model system, and he is having trouble working with the ChatGPT API, or he's having trouble with a VLLM inference issue or whatever. Right? So super funny. What was also really weird was when I had this is gonna be really meta. When I had the GUM window open with the propositions, and I was saying no or yes to the propositions, that stuff would be fed back into the GUM. Right? So it's Omar is unhappy with the inference about
Will
this.
this influence the
Yeah.
later influence?
Yes.
Okay.
It's
That's
super
insane.
weird, right? I mean, I guess Michael Ryan, co-host, was telling me about this time where he's working on something kind of similar, where he was sort of he told somebody that this PowerPoint presentation generated by my GUM system sucked. And it went back and it was I tried to improve it, right? Because it could observe that the person didn't like it.
Yeah, even though you describe more a funny example, but I do think this can have huge societal impact, because nowadays many people are trying to use AI to kind of improve their productivity.
Yes.
Right? But a lot of time, I do see people struggle because they don't really know what I should ask
Yes.
my model to do,
Yes.
or whatever.
Yes.
So basically, if it can really suggest at the correct point, it can really bring this benefit of AI to more people.
Yes, absolutely. I think something that is awesome from a lot of participants who use the system. They were sort of I wouldn't have thought to ask the model. It would have never occurred to me to even think that AI could help me in this setting.
Yeah, I think this is super cool. It's when I ask this mind-blowing question, I'm more thinking about fun example, but actually all examples you describe, I see very concrete benefits,
Yes.
right? Suppose I'm a programmer. I may not even realize this is a bug I need to fix,
Yes.
but if the AI can just remind me,
Yes.
that's a huge thing.
There's a participant in the study who was I did not think of asking the model to write this code to speed up my data set loading stuff.
Oh, whoa, that's
Yes.
interesting.
Yes. So they were it analyzed this file and it told me that the bottleneck in loading was actually loading images. That was the bottleneck in my get item function or whatever. And they were I wouldn't have thought to ask the model to do performance enhancements. They didn't come to me. They didn't I didn't appreciate that the model could even do that. I think a lot of the ones that are really cool for users are the ones where the user sort of I did not realize this model could, do performance analysis. I did not realize this model could look for recommended movers. I did not realize this model could help me write a better cover letter in this moment. I did not realize this model could help me do background research on related papers.
It's
right?
more even helping them to untap even some of their potential. Right?
Yes.
It's as a person, sometimes I don't really know I can do so much, but
Yes.
GUM can actually suggest or
Yes.
even tell me, wait, you can do more.
Yeah, it's an accelerator, but I mean there are cons to this, right? As in a lot of the old social computing problems become relevant again, right? Filter bubbles, your models recommending things that maybe are not productive for you, right? I think one of the things that are also interesting about the GUM paper is sycophancy. Do you want your model to always be yes? I mean, there are these aligning general user models becomes like a far more interesting and challenging problem when you consider alignment across anything and not just what a user can ask. So like, again, like I think this is coming back to like the...
I see. It seems to be exaggerating both the benefit and also the potential harm of
yes.
the AI itself.
Yes.
I see.
So I think like, I mean, there are a lot of like filters that we've kind of added to the GUM architecture, but I think like this opens like a pretty critical like space for people to work on like both like technical like work in terms of how do you like construct better GUMs or construct like align GUMs or like train GUMs to be like complementary to the user. And it also opens interesting socio-technical problems, like how do people moderate GUMs? What does it mean for people to like fall into filter bubbles with GUMs? And I think like that raises a lot of like really interesting questions.
Yeah, this is super exciting. I feel even after this interview, I just really want to try out GUM to run not just days, weeks, or even months on my computer to see what your GUM say about
Yeah,
me.
one of the interesting things I did not discuss here, like I forgot to mention, was like we did not think people would use this system as like a reflection tool. It's super interesting.
No, I would like to use it. That's why I'm just
yeah,
saying.
no, yeah. Like I think people were not even using it for the suggestions. Like sometimes, like some participants were like, I think it just helps me reflect on what I actually do on my computer. Like they're like, oh, I didn't realize I wasted so much time watching Twitch streams. Like, or oh, I didn't realize like I, was maybe potentially like being like if it help people for like negotiation. I didn't realize that like I could have negotiated more in this setting, or I didn't realize that like I prioritize communication with my advisor over other people. I didn't realize these things about myself. So a lot of people did end up like reflecting based on like just looking at the inferences made by the GUM.
This is actually very, very interesting. I think this brings back to like why this human-centered technical work is really important. Is like it's really unlock a lot of potential. Many things I think people won't go to reflect by just chatting with a chatbot.
Yeah.
And now suppose we have a GUM on my computer.
Yes.
This actually enables me to even become a better self. I
Yes.
think this is the beauty and also why we really enjoy this line of work. And
Yeah.
we really appreciate the time today to share all this. And I think all the work about GUM is open source. And for all the audience, if you are interested, feel free to check out the URLs.
Thank you. Yeah.
Thank you so much.
Yeah. Thank you guys for listening.
Thank you, Omar.
It was wonderful.
Thank you.
It was wonderful being on the AM podcast. Yeah.